Welcome to clickmyproject.com. Now we are going to discuss about title of our project. Our project title is DBR-MAC, a depth-based routing-aware MAC protocol for data collection in underwater acquisition sensor networks. Now we are going to discuss about the abstract of our project. Our project abstract is: due to long propagation delays, routing discovery is very expensive in underwater acquisition sensor networks. Therefore, depth-based routing, that is DBR protocol, are usually preferred, whose routing discovery cost is almost zero. However, DBR protocol working with broadcasting a medium access control MAC, bringing a server collection of, especially in the data collection network. Moreover, in DBR, all the packets are forwarded from deep to shallow nodes along the direction towards the sync node. The directional packet transmission may lead to load imbalance, where some nodes undertake most lead, and we call those nodes key nodes. However, the majority of the existing MAC protocol cannot provide the key nodes priority of accessing the channel in the collision domain. It is necessary to design the MAC protocol coupling with the DBR. In this project, we are adopting the cross-layer approaches to proposing a DBR-aware MAC protocol called DBR-MAC, which smoothly integrates in a handshaking-based MAC and DBR protocol. It improving the throughput, energy and time efficiency at the cost of fairness. A depth-based transmission scheduling scheme is introduced based on the depth information, angles information, and overheading a one-hop neighboring nodes transmission to make a key nodes have higher priority to access the channel than other nodes. DBR-MAX is a cross-layer scheme, and it is directional forwarding tiers based to forwarding the packets from the source to the floating sync node by the least hops. Moreover, an adaptive depth-based backup algorithm cuts down the backup time for nodes and preventing the congestion at a key nodes. Extensive simulations show that the throughput, energy and time efficiency of DBR-MAC outperforming the existing MAC protocols when applied in the data collection network. Now we explain about flow diagram of our project. This is our flow of our project. First one is a network formation. The network formation containing a nodes, that is mobile sensors nodes and sonobuoys. Sonobuoys is nothing but it is a surface node. Considering an under wireless sensor network, sensors equipped aquatic swarm architecture. We have a large number of mobile underwater sensors nodes at the ocean bottom and sonobuoys, also named a sync node, at the ocean surface. Each node is with the various sensors devices and with the low bandwidth aquatic modem, which is used to periodically report the sensory data to the destination sonobuoys, so that the sonobuoys is a destination node. Next one is a periodic beaconing plays an important role in DBR routing. It is through the periodic beaconing that each node obtaining the location information of its neighbors and reachable sonobuoys. In the beacon messages, each sonobuoy is embedded in a sequence number, unique ID, and its X and Y axis location. Each sensor nodes location through the localization services. Next one is if the routing process. If the DBR routing, that is a depth-based routing, is done. If sensing the depth-based routing means it will sense a routing establishing, then the next find the next best hop. If the DBR routing is not valid means goes to uncheck the DBR routing based on the position and the data collection. Here the collecting all the information of the sensors nodes and monitoring the networks. Whenever a sensor node has a packet to send, it should determining which neighbors and qualified to be the next hop forwarded. The next box hop forwarded send it composed of the most suitable nodes from the next hop candidate sets. Void node recovering the process is used to when the nodes fails to forward to the packets using the greedy forwarding strategy. If the node is in the communication void recognition, that is it does not have any neighboring loading and the passive propagation toward the some surface sonobuoys. If the data collection node collecting all the information from the mobile nodes and forwarded to the sonobuoys, then the performance analysis is done. The performance measures are in the three metrics. Throughput is nothing but the throughput is the rate of producting or the rate of which something can be processed. Throughput is the rate of success of messages delivering over a communication channel. How many packets sent at the times of transmission. Our proposed system will give better result than the period work. Message delivery ratio, that is a packet delivery ratio. Many protocol in the wireless sensor network using the message delivery ratio MDR as a metric to selecting the best route transmission rate or a power. Next one is a delay. We comparing our system delay with the existing system. The period work have a high delay than our system. Next one is an energy consumption. When we comparing with our energy metric with the existing system. Let us discuss about output of our project. First, open the terminal window. Then now change the directory. Now the current directory is root home. Our directory is DBR-MAC. So directory coding command is cd space DBR-MAC. Now change the directory root into DBR-MAC. Then type ns space main.tcl. This command is used to run our main file. Now run the project. Here we finding the broadcasting size and my position, that is the current node position and the neighbors node position, that is x-axis and the y-axis. Then now I type nam. The nam file is used to open our output file. This is our output now. This is zoom in button and this is zoom out button. This is rewind button, playback button, stop button, play forward button and fast forward button and stop button. Now I play the project. Here the sensor node is deployed. The magenta color node indicates the sonobuoys and the blue color node indicates the data collector nodes and the green color node indicates the sensors nodes. The data collector nodes moved to the sensors and collected the information and forward to the sonobuoys. Here the data collector sends the communication to the sonobuoy nodes. Now I explain about graph file. So I type xgraph space thr.exe. This command is used to explain our throughput of our project. Next one is xgraph space pdr, that is packet delivery ratio of our graph. Thank you for listening. Our demo is completed.